Hi, for this recording, I'm going to show you how to model a process by differential equation and also solve it by the software PPLANE. Imagine that there are two tanks containing liquids, each of them 50 gallons of liquid there, and the first tank have salt content, they call it X here. Let's say initially there are 12 pounds, and the second tank initially there is no salt there, and these tanks are interconnected. Initially, fresh water are pumped into tank number 1, which contains salt there, at 8 gallons per minute. And they assume that the tanks are well stirred. At the same time, 9 gallons of this water from first tank is pumped into second tank per minute. And from the second tank, it returns 1 gallon per minute to the first tank, and also release 8 gallons per minute. Or the liquid content in the tank is always maintained at 50 gallons. So let's try to solve this equation. We know that the salt content is always changed. X is changing with time and Y is changing with time as fresh water are pumping in and they are releasing it. So how do we model it? Let's look at the equation. So we know X is changing with time, so we can write down dx dt that for the first tank it released 9 gallons per minute. Now 9 gallons is out of 50 gallons. Assuming that the liquid are well stirred, then the amount you put out, the pump out from the first tank is 9 over 50 times x. So since it's going out, so there's negative, this is decreasing. And also, the tank number 1 also received 1 gallon per minute from the second tank. So the amount of salt it received is 1 out of 50 from y, assuming that the content is well stirred. Now let's look at the rate of change of y. We know that it receives 9 gallons per minute from tank number 1. So the amount of salt received is now about 50 times x. And it release 1 gallon to the left to the first tank and release out another 8 gallons. So total release 9 gallons of liquid. So it releases 9 out of 50 y. This is the rate of change. Therefore, let's look at the equation again. I convert them into decimal point. I'm going to use the PPLANE to solve it now. So I call up the Java version of the PPLANE. Okay, so Java version of PPLANE, and I'm going to enter the equation. So the equation in this case, x prime is equal to minus 0.18 times x, and then plus 0.02 times y. This is the first equation. The second equation is going to be 0.18 times x minus y, or y prime. Okay, and then I want to change the parameter. Maximum is 16, right? So I can put maximum x is 16. Minimal I keep it at say minus 2. And for y content, initially the y is 0. Right? Say I keep the maximum of y, let's say to 8. Then I'm going to graph the phase plane. So from the phase plane, we notice that the point, for example, 0, 0 is look like a sink. We can confirm it also, but let's look at a solution here. I want to use the keyboard solution now. The keyboard solution asks me to input the initial value of x. Initial value of x is 12. Initial value of y is 0. So I press solve. So you tell me this is how When x equal to 12, y equal to 0, eventually it goes to x0, y0, where subcontent becomes 0. Now let's look at how does the content of salt in each tank change with time. You can do a graph called both xt and yt graph. Then ask you to select the solution curve. So I'm going to select the curve where x equals 12, y equals 0, and click. And you can see that when time t equals 0, x equals 12, and time t equals 0, y equals 0, where x is the blue curve, y is a red curve, you notice that the subcontent is decreasing with time. And more or less, we can feel that around, very safely, you can say that about 43 or 44, the subcontent could be going to 0. So this is how we solve this equation graphically. And that is the end of the recording.